So it's important we see how percentages questions could come up in the National 5 past papers for both the maths and the apps, because there's slight differences at times between the two of them. So I'm going to look at some here, give you an example of different skills, calculator and non-calculator, from both exams. I want you to pause it on every single page and have a go at them, and I'll show you the work solutions and tell you where the marks come from for each one. So here's the first one here. These are both from mathematics papers. The first one is a non-calculator reverse percentages. Second one is a calculator reverse percentages, to give you a bit of an example of both. So have a go at them and then we'll go over them together. So the first one, whenever we do a reverse percentages question, we always ask ourselves the same thing. What percentage do I have now? What's it equivalent to? And then we scale it and we scale it up. The first question is, what percentage do I have? Well, this one here is reduced by 20%. So it's essentially 100% take away 20%. So we now have 80% of our total. So what I know is that 80% is equal to that sale price of the dress, which is 720. Now we do what we normally would. We scale and then we get to our original, which is 100%. Now in a calculator question, I would always say scale to 1%. It just makes it easier. However, in a non-calculator paper, sometimes that can make your life a little bit trickier. So let's scale to a pertinent and relevant percentage. Well, 80%, I know if I divide 80 by 8, I'm going to get 10%. And if I have 10%, I can multiply it by 10 to get the original. So that's what I'm going to do. I'm going to do my scaling by dividing by 8 to get what 10% is, and then timesing by 10 to get to my original. We have to treat this side the exact same, like an equation. What you do at one side, you do to the other. So I'm going to take 720, and I'm going to divide it by 8, and then I'm going to tell my answer by 10. So 720 divided by 8, that gives me 90. 90 times 10 gives me 900. So I can say fine, so the original price is equal to £900. So there you go, original price is that. Typical question like this will be worth about 3 marks. 1 for realising here what your percentage is. Your second mark for your scaling. Now, it's important to realise I've scaled to 10%. The scaling doesn't matter what you go to as long as it's worth working through and as long as you can get your solution from it. I could have gone to 5%. I could have gone to 1% if I wanted to in a non-calculator. The choice is yours. The scaling has to be consistent though. And then my third mark comes from my solution, my original price. If we look at the second one though, this is now a calculator question, and you'll notice there's slightly more complex numbers. It's 278.40 and an increase of 16% rather than a nice round 20% in that one. But it doesn't change our steps. The first thing we have to do is figure out what percentage we now have. Well, an increase of 16%, that's the equivalent of doing 100 plus the 16. So what that tells me is I now have 116%. And that equals the amount I've got, which is £278.40. Now, because this is calculator, I would always scale it to 1%. Force of habit, I would always scale it to that. If you scale it to something different, there's no issue there. Just be consistent throughout this question. So I would scale it to 1% by dividing by 116. I'd then times it by 100 to get the original price of 100%. And again, I'd do the same to this side. Treat it like algebra. What you do to one side, you do to the other. So I'd divide by 116 first, and I'd then multiply it by 100. So if I divide by 116, what I'll end up getting is 2.4. And if I then times it by 100, I'll get 240. So what that then means is my original price for the car insurance is equal to £240. You'll notice I'm contextualising it, I'm using units, and I'm putting it back in the scenario we had. Similar to the first one, the 3 marks firstly come from figuring out the percentage, secondly come from the scaling, and third mark comes from the final solution. So there's a couple of examples of reverse percentages. This one here, we're looking at compound interest. Now, compound interest is a calculator question. It'll come up in the calculator paper. However, you'll notice that the first one is a maths paper question. The second one comes from applications of maths, and look at the slight differences. Maths is a set increase over a set number of years. Applications of maths can be similar to the maths paper, where it's a separate increase over a number of years, or we can also see questions that look like this, where it's an increase over a set time, a decrease over a set time, and it's a solution at the end of it. So I'm showing you an example of that here. It's not always, remember, but that's very typical. So pause and have a ping. Let's see what you do. So the first paper question here. Remember, for this, we need to know three things. We need to know our original amounts. We need to know our multiplier. And we need to know our time scale, which is going to be our power. So the original amount in this case is the 118,750. My multiplier, well, it's an increase of 4%. So remember, it's the percentage we now get, which is 104%. But as a decimal number, so 104% is 1.04. And my time scale is over the next 2 years, so it's going to be 2. So I can then say, fine, my solution is going to be given by the 1.04 to the power of 2 times the 118,750. Like I say, it's a calculator question, so just fire that in the calculator and get your solution out. And when you do that, you get 128,440. There's your final solution there. So, fairly straightforward, quick, easy set of steps. Solutions and marks for this come in here. So you get 3 marks typically. You get 1 mark for your multiplier. You'll get 1 mark for your power setup like that. And you'll get 1 mark for your final solution. Now the applications of maths question, as I say, very often it will appear similar to the maths one, where it's an increase over a set of time or a decrease over a set amount of time, and it follows that. You do get some of the format that is here. An increase over a set amount of time and a decrease over a set amount of time. So it requires a little bit of extra work. But that's no issue at all. It just requires a few bits more thinking. So let's look at each part here. So my decrease of 4.2%. Well, that goes down by 4.2%. And if I was to get a multiplier for that, what I'd end up with is 0.958. So if it was just a decrease of 4.2%, that's the multiplier I'd have. If it was an increase to the 5.3%, I'd end up with 1.053 as my multiplier there. So I know both multipliers for that. Now what I also know is that this second one is an increase over 2 years. So if I were to do it on its own, it would be 1.053 to the power of 2. However, initially I've got my decrease. So it's going to be 0.958. Now what you've got to remember is I'll do my decrease, I'll get my solution, and then I'll do my increase. So it's technically the same as me saying 0.958 times the 1.053 squared times my original amount, which is 240,000 in this case. So it could be done as one big calculation. However, if I did it as 2 separate ones, so let's say I did the 0.958 times the 240,000, and then I took the answer for that and did 1.053 squared times whatever that answer is, so I broke it to 2 steps, I'd be perfectly fine as well. I could recognise in 1 go or 2 goes. There's no issue there whatsoever. Do whatever works for you. The bottom line is, for both of those, I should get the same solution. And in this case, it's 254,937.3 and then a whole spiel of stuff. Now you've got to make sure you read the question as well. There's an important thing. Round it to 3 significant figures. Quite often that bit gets overlooked. Please don't fall into that trap. If it gives you a rounding, use the rounding. So 3 significant figures, that becomes 255,000. And then put it in the context, bottles per year. I'm following the instructions the question gives. So there you go, 2 slightly different ways that they're done for a maths and an apps paper. Now the apps one, you get slightly more for it in this case because you get 1 for the first multiplier, 1 for the second multiplier in this question. 3rd mark for plugging it all together as your calculation and getting a solution out. And then your 4th mark is for the rounding. So slightly different in terms of the marks because of it, but still the same base set of skills when it comes to compound interest. Our last question I want to look at is from the Applications of Maths 2025 paper. It's paper 2, question 10C. Now quite often apps of maths will have bigger questions split up into parts, but they won't be reliant on solutions from previous parts, which is a good thing to do, to be honest with you. It'll let you just develop skills and not feel like if you can't get a part A and a B, you've lost C already. Now this one here is all about representing something as a percentage of another, so similar to what we've encountered in the past. So have a go and come back and look. Now this one asks the percentage increase, which is this part here, in the distance he wants. So remember, to represent a percentage increase or decrease, I first need to know what my change is. Well, in this case, to get the change, I do 7.2, take away 5.6. Because he's gone from the 5.6 to the 7.2, what I end up getting then is 1.6. Then I can get my percentage at that point. So in this case, it's the change, the 1.6, divided by the original. So look at the question. Before starting the program, you could run 5.6. So it's 1.6 divided by that 5.6, and then it's times by 100. Now this is a calculator question. Again, it's in paper 2. So we can just plug this all into the magic number machine and get a solution out. And when you do that, you get 28.57 and a whole spiel of stuff out from there. Round it off, I typically go to 1 decimal place, 28.6%. If you went to 29%, they wouldn't penalise you because they've not given you a set amount of rounding to do in the question. Don't go to 30 though, that would just be a bit silly. A question like this, 2 marks. Seems like a lot of work for 2 marks, but it's 2 marks and it's fairly straightforward. 1 for the change and the second one for your solution and knowing how to convert it to a percentage. It's a fairly standard, straightforward set of marks. These are just some examples of how these could come up. Now, I'm not saying this is exhaustive and that this is how they'll come up every single year and how they'll only be laid out. They're typical questions. Don't rely on it being the only way it can come up, but if they come up like this is how you lay it out, this is how you approach it, and this is how you get the solution. Good luck.